All right, guys. So we're going to go back a little bit. You've seen a formula for dealing with um, powers. And so something like, 8 to the x or, 4 to the x squared. You've had, there's a formula out there on the derivative uh, side or the handouts that I've given you, but let's just kind of deal with it with like a special technique or the ability to solve it using algebra and some logarithm rules. So let's say we're dealing with this, y equals a to the u. So if I want to find dy dx of this piece right here, then what I would do is I would take the natural log of both sides. So let's just kind of work this. So if I took the natural log of both sides, I get natural log of y equals the natural log of a to the u. Now, if I use my natural logarithm rules, I get the natural log of y equals u times the natural log of a, which that's a constant right there. So from here, if I took the derivative of this piece, I would get 1 over y for the natural log of y times dy dx equals u prime, because I take the derivative of u prime, times the natural log of a. Now, when I get to this piece, I need dy dx, because remember, I'm finding dy dx. So I'm going to multiply both sides by y. So I get dy dx, which is equal to u prime times the natural log. Natural log. Let's go back 2 strokes there. There we go. Natural log of a times y. So this pretty much looks like a formula, and you can manipulate it a little bit more and put it back up here. So the natural log of a to u prime times y. Okay? All right, so the key is using the natural log when you're dealing with exponents like this. So let's take number 3 on your worksheet, for instance. Let's just tackle number 3 on your worksheet. And your worksheet for number 3 gives us y equals 2 sine of 3t. So let's just follow these steps right here. All right, guys, my computer was freaking out last time, so hopefully I can splice this together. Or you're getting 2 videos. So let's just apply this here. So we can take the natural log of y times the natural log of 2 sine of 3t. Well, from here, we can apply our properties. So we get the natural log of y equals the sine of 3t times the natural log of 2. Well, if I take the derivative of the left, I get 1 over y times dy dx. If I take the derivative of sine 3t, I get 3 for the inside. Derivative of sine is cosine 3t times the natural log of 2. Now, I got to clean this up like we did on this other side. So now I am right here. So this step matches that one. This step matches that one. So now I'm right here to where I need to move this around, and I can get dy dx equals 3 cosine of 3t times the natural log of 2 times 2 sine of 3t. Because if I multiply both sides by y, like I did here, well, y is equal to the original problem. So I end up with, that's not an exponent, that should be down inside the problem here. That should be 3t. So I've got this piece here, so technically that's the answer. Sometimes they'll finish them a little differently algebraically, and they'll say the natural log of 2, 3 cosine of 3t times 2 times the sine of 3t. And that is basically that one there. So rather than memorize this formula here, which you're welcome to do, you don't really have to, because the idea is, and actually this is going to be a to the u, which is up here. You don't have to, because you can just follow the rules here. So you can either use this formula, natural log of a to the u prime times a to the u, and memorize that and know exactly what you're dealing with, or you can learn how to tackle this using this special technique. Now, so I would choose to kind of deal with, anytime you see these types of exponents like this, take the natural log of both sides. It kind of cleans it up a little bit better. But that's what they mean by the special technique on worksheet 29. Good luck, guys.